Welcome to the Explainer. We're jumping right in today because we are unearthing something absolutely incredible. An elegant, ancient data storage system that seamlessly blends math, linguistics, and art. It's literally a code proving that our ancestors were archiving insanely complex data long before the first computer ever got plugged in. So let's dive into this massive challenge ancient scholars faced. Picture this. You're a brilliant mathematician or astronomer centuries ago, right? You've calculated these incredibly complex figures. But you live in a world way before written mass media, thumb drives, or the cloud. How on earth do you make sure your precise, highly complicated numerical discoveries actually survive without getting lost or miscopied? Well, you turn them into poetry. The ingenious solution to this was Katapayadi. You might also know it in the Malayalam language of Kerala as Peru or Akshara Sankhya. This brilliant mnemonic device allowed scholars to seamlessly encode massive, highly complex numbers into super memorable sentences of prose or poetry. So instead of trying to rote memorize a dry string of random digits, you simply had to memorize a beautiful verse. It's like a giant puzzle, but for data storage. To really grasp how this works, we need to look at the cipher itself. The whole system uses Sanskrit consonants to represent numbers in the decimal system. The first consonant, ka, gets the value 1. The second, ka, is 2, and so on, right up to ja as 9 and nia as 0. Now, because there are a lot of consonants in Sanskrit, the numbers are then just assigned to the next set of 10 consonants in the exact same way. What this means is we end up having multiple alphabets representing the exact same number. They act as the fundamental keys to our decoder ring. For instance, the number 1 maps to the alphabets ka, ta, pa, and ya. And hey, when you pronounce those together, you get the system's name, Katapayadi. Okay, so the absolutely crucial point here is understanding these 3 simple rules. Master these and you unlock an endless possibility of mathematically encoded literature. Rule 1, the consonants give you the numbers. Rule 2, the vowels or swaras hold 0 numerical value, literally none. They act purely as filler to embellish the words, which lets the author hit that perfect poetic meter. And finally, Rule 3, you decode the digits by reading their place value backwards, from right to left. Let's see this right-to-left decoding in action with a quick example. Take the word Rama. The consonants correspond to the numbers 2 and 5. But remember Rule 3, because the least significant decimal place is written first on the left and the most significant on the right, decoding Rama from right to left actually gives us the number 52. It's incredibly elegant. In fact, this entire scheme of mapping numbers to alphabets was perfectly summed up in just a single line from the text Ratnamala, which is a mathematical treatise written by the scholar Shankara Varman back in 1819. But while this 1819 text neatly packages the cipher, the roots of the system actually stretch back much further into history. And, its applications are truly mind-blowing. Just look at what happens when we decode a specific verse from the Sathratnamala text. When we apply the Katapayadi matrix to that single verse, it reveals the value of pi correct to 17 decimal places. The last digit is even rounded up to 4. I mean, think about it. Since Katapayadi doesn't have a way to encode a decimal point, the digits just flow in sequence. Memorizing 17 random digits is incredibly tedious, but encoding that value into a rhythmic, poetic verse, it makes it beautifully easy to recall. Of course, a mathematical tradition this robust didn't just pop up overnight. It was sustained, tested, and perfected over centuries by some of the most brilliant minds in Kerala and way beyond. From Vararuchi in the 4th century CE all the way down to Venkatamahin in the 17th century, this system was heavily relied upon for everything from deep mathematics and astronomy to the fine arts. It honestly acted like an ancient spreadsheet, flawlessly cataloging massive amounts of data. Take the 14th century mathematician Madhava, for example. He used Katapayadi phrases to encode trigonometric sine functions from 0 to 90 degrees, and he did it in precise 3.75 degree steps. Even earlier, Vararuchi's 4th century Chandravakyas contained 248 sentences that flawlessly represented the numbers needed to calculate the exact position of the sun and the moon for literally any time of the year. But here's where it gets really wild. This cipher wasn't just for math and astronomy geeks. It actually formed the backbone of an entirely different discipline, the beautiful world of classical music. One of the absolute coolest examples of Katapayadi is how it's used in the Melakarta system of South Indian classical music. For context, this system is a collection of 72 parent melodic scales, known as sampurna or complete ragas. Within this Malakarta system, the very names of the musical ragas are holding a secret mathematical formula right there in their first two syllables. Let's look at the raga named Lathangi. The secret is hiding right there in plain sight, in those first two syllables, La and Tha. Now, what's so cool here is that when you decode those syllables, La and Ta, using the Katapayadi cipher we just talked about, you get 63. And wouldn't you know it, 63 is the exact numerical position of this specific raga in the 72-scale Malakarta sequence. We see the exact same thing happen with the raga Charukeshi. Apply the code to its first two syllables, and bam, we get the number 26, which is its exact position in the sequence. It's brilliant! By knowing just the name of the raga, singers could figure out its number, and from there, instantly establish the ascending and descending scales just by doing some quick mental math. Now, of course, any complex rulebook that's been tweaked and refined over centuries is going to have its outliers. A handful of ragas, ones like Chakraragam, Divyamani, and Chitrambari, they deviate from this naming sequence for their own unique historical reasons. But the vast majority, they adhere perfectly to this brilliant musical mathematical code. And it doesn't stop at math and music. The system also allowed authors to hide these incredibly clever historical timestamps right in plain sight within their poetry. A truly perfect example of this comes from the Narayaniyam. It's a famous 16th century Sanskrit devotional hymn written by the celebrated mathematician and linguist Melpathu Narayana Bhattacharya. The hymn wraps up with this beautiful blessing, Ayur Arogya Saukyam, which literally translates to a promise of longevity, health, and happiness. Sounds like a standard, lovely sign-off, right? But it's so much more than just a wish. When you apply Katapayadi to these specific words, it decodes exactly into the Kali Dina Sankhya. That's a parameter used in Kerala astronomy that counts the exact number of days since the start of the Kali Yuga. So that hidden number actually marks the precise day the author finished writing the manuscript. How cool is that? But wait, there's more. One of the most fascinating possible applications of Katapayadi points to an era much, much earlier than the BCE period. It's hidden right in the original title of the ancient epic, the Mahabharata. See, the original name given to this monumental epic by its author, Vedavyasa, was simply Jaya. Well, when decoded through the Katapayadi system, the name Jaya gives us the number 18. Now, if you are familiar with the epic at all, you know that 18 is definitely not just a random number. It's actually the foundational structural code that repeats throughout the entire massive story. Just think about it. The Mahabharata is divided into exactly 18 volumes. There are 18 chapters in the Bhagavad Gita. The epic, decisive battle lasted exactly 18 days. And it involved exactly 18 armies. This perfectly structured recurrence isn't just a coincidence. It presents a fascinating theory that mathematical ciphers like this one might have been used to encode and literally shape our greatest stories since antiquity. So you might be wondering, why was all of this necessary in the first place? Well, much of the work of our ancestors was written on tangible, highly perishable materials like palm leaves. Because physical manuscripts rot, burn, and disappear with the passage of time, this seamless blending of left-brain math and right-brain poetry became the ultimate defense against forgetting. It relied heavily on Shruti, which is the oral tradition of acquiring and passing down wisdom through the spoken word. It ensured that this complex data outlived the physical paper it was written on. Which brings us to a really crucial point for today. The survival of these incredible knowledge traditions doesn't just depend on the past. It depends entirely on us. We have a choice to become aware of these traditions and commit to keeping them alive. Will we take up the mantle and speak them into the future, or will we just let this brilliant fusion of art and data fade away entirely? So, what role will you play in keeping the code alive? I really hope this explainer sparked your curiosity to look a little closer at the hidden codes all around us. Thanks so much for learning with me today.